Hello, advanced algebra students. I hope you are doing fantastic. I know I start off the same every time, but I really, truly do hope that you are doing well. We are almost done with notes for this year of math, which I'm sure you're very excited about. We've already learned how to graph, evaluate, and compare logarithmic functions. This lesson is going to focus on properties of logarithms that we can use to either expand or condense them. It also reviews a change of base formula that allows us to use our calculators to evaluate the log of any number using any base. So that's kind of handy. So I do have the three properties that we need to use for our notes today already written out. This is the logarithmic property that tells us if we're taking log base b of a product, it is equivalent to the sum of the logs. If we are taking log base b of a quotient, it is equivalent to the difference of the logs. And we also are learning here that if we are taking a log of something raised to a power, we can move that power to in front of the logarithm, and those two are considered equivalent. All right, we're going to do some examples using this fact. So we are going to we are going to expand some logarithmic expressions. Let's take a look at log base 5 of a squared times b to the 7. We can see that there is a product here, so we can break these apart and write this as a sum of the logs. Now we can see that we have exponents here and that these can be moved in front of the logs. So this is going to be 2 times log base 5 of a plus 7 times log base 5 of b. And that would be a fully expanded logarithmic expression. Now, let's go ahead and take a look at example number 2. So example number 2 is we're taking log base 7 of r cubed t to the 4th all over v. So I like to see this as a quotient first. So I would take log base 7 of r cubed t to the 4 minus log base 7 of v, because I can see I have a quotient, so I need to take a difference of the logs. Then I can see I still have a product here, so I would break those up as log base 7 of r cubed plus log base 7 of t to the 4. And then the last thing that I would do is take any of the exponents that I had and move them in front of the logs. So then I would write this as 3 times log base 7 of r plus 4 times log base 7 of t minus log base 7 of v. All right, I hope that was helpful. That is called expanding our logarithms. Now we're going to work backwards and condense, because any of these properties, we can go either from left to right or from right to left. So let's take an example, for instance, here at 4 times log base 4 of m minus log base 4 of n plus 3 times log base 4 of p. The first thing that I would like to do is to bring the exponents back up where they should be here. So let's see. In both of those cases, I can move the exponents. So I'm going to write this as log base 4 of m to the 4 minus log base 4 of n plus log base 4 of p cubed. All right, then I think it might be a little bit easier if we kind of put the two that are being added together. So we can say log base 4 of m to the 4 plus log base 4 of p cubed, and then have the subtraction on the n. These two, we know, working backwards, came from a product. So this would come from log base 4 of m to the 4 times p cubed minus log base 4 of n. Then what I want to do is take into account this minus sign here. So I'm going to write log base 4 of m to the 4 p cubed over n. And that would be my final example, or answer I should say, for example 3. Okay, let's do one more kind of like that. I have a few to choose from here, and I'm kind of trying to decide which one is most representative for you. Let's do example number 4 with this problem. So let's do 1/3 times the natural log of 64 minus 2 times the natural log of 4y. Okay, so in this case, I'm going to bring my exponents up. So I'm going to have this as a natural log of 64 to the 1/3, and then I'm going to have this as minus the natural log of 4y quantity squared. I do need to distribute that 2 to both items. So, and then also the cube root of 64 is 4. So this is going to be the natural log of 4 minus the log of 16y squared. Now, because there's a minus sign, I know that came from a quotient, so this is the natural log of 4 over 16y squared. And then because 4 divided by 16 is 1/4, I can write all of this as the natural log of 1 over 4y squared. Okay, so we've talked about expanding, we've talked about condensing, and I want to make sure it's still recording. It is, that's good. I didn't know if the phone ringing would have stopped the recording. I'm glad it didn't. Let's look at one other concept, and that is the change of base formula. So that is the fact that log base b of m is equivalent to log base 10 of m over log base 10 of b. Now this looks kind of confusing, but what I like to do, and it is in my mind, kind of draw like an invisible line here, and just think of this as the log of m over the log of b. Because remember, when we say base 10, it's equivalent to just saying log. So let's see how we can use this on our calculators. Let's say that we're trying to evaluate, this is our last example here, log base 2 of 7. Using the change of base formula, I know this is equivalent to log base 10 of 7 over log base 10 of 2, or just the log of 7 divided by the log of 2. I can enter both of those into my calculator, and I get about 2.807. All right, I hope this was helpful. Thanks, guys. Bye.